Hi there, I'm Chris Saxon, and today we're going to continue the Red Candy series. In this episode, we're going to ask another question. How many indexes do you really need? Ready? Let's get started. So far, we've identified two key queries that we're going to be asking about our candies here. The first one comes from my daughter, and she's going to be asking me, how many red sweets are there left, Dad? How many are red? She just wants to know how many there are so she can have some idea of how much she's going to get to eat. However, I've got different concerns. I want to know how many are red, but I'm also concerned about how much sugar she's getting. So to know this, I want to know the weight of the sweets that she's consuming. So I want to know the total weight of the red sweets. So we've got our two different queries. How many are red? And what's the weight of those red sweets? And we've seen in previous episodes that there's two different indexes we can create to give these optimal performance. However, each extra index we add introduces overheads to the database. Let's take a moment to remind ourselves what those are. There's two key overheads that adding more indexes to your tables in your database adds when you do so. First of these, increased storage. So we've seen so far, we're going to create two indexes on my sweet table here. So first one just on color, and we're going to create a second one, larger one, on the color and the weight. So as we're adding more and more indexes to the table here, we're increasing our storage requirements. Second issue is we're adding our overheads every time we change the contents of the table. So when I buy more sweets and add them, or my daughter eats them and takes them away. So if we see I've got some sweets I've just bought, need to add them. So get the first one, got to put it in the appropriate location, and then I've got to go and update both of the documents at the same time so they remain in sync. And each additional index we add just increases the amount of work we got to do when we add, remove, or update index columns. So with this in mind, with these overheads imposed on us, it's worth asking ourselves, can we answer our queries here with just one index instead of two? Let's see. Let's just take a moment to remind ourselves what our two queries are. First one, count how many of the sweets where the color is red. To support this query, we created an index on the color, just the color column. Our second query, find the sum of the weight of all the sweets where the color is red. And to support this one, we created an index on the color and then the weight. So there's a couple of things to notice here. First up, both our queries have where color equals red in the where clause. Therefore, they can both potentially use an index where the first column is color. Second thing to notice, both our indexes do start with color. The leading column of both of them is color. Therefore, there's a good chance that one of these is redundant, and we can get away with just creating one of them, which is good news. We're reducing our overheads. However, which one can we get rid of? Well, let's remind ourselves why we created them. We were doing this so we could get nice, efficient, index-only scans for both the queries, so we didn't need to actually pick up the candies from the table at all. Now, our first query, count how many sweets are red, can still do this with either index. You can do it whether it's just on color, or it can also do it whether the index is on color and weight. Both of them are index-only scans. However, our query to find the sum of the weight of the red sweets needs the larger index, otherwise, still got to go to the table to find how heavy the red sweets actually are. Therefore, all other things being equal, we'd prefer to go with a larger index in this case, because it gives good performance improvements for both our queries, and we can get rid of our single column color index and minimize our database overheads. Let's recap. We've seen that if you're considering creating two indexes on your table, one on columns A and B, and a second on columns A, B, and C, then the leading columns in both of those indexes match, and really you should only create one of them. How do you decide which to choose? Well, remember that the larger index, the ABC index, requires more storage and will have greater impact on your DML, your inserts, updates, and deletes. However, it will improve the performance of the queries that you've designed it for. So how do you choose which index to go with? Do you choose the smaller one or the larger one? Well, to answer that question, you've got to take a look at the following things: how much data you're storing, how often it's changed, how often you query it, and how fast those queries need to be. Let's take a look at some examples. First, let's consider our candy here. I'm only buying new sweets a couple of times a month, so our rate of inserts is low. Also, I only let my daughter eat candy once a day, so unless she's sneaking some without telling me, we only delete candy once a day. Either way, the rate of change of data is low. Also, we've only got a few hundred candies here at most, so our storage requirements are small. So we're okay going with a larger index here. Our overheads aren't too great. So let's now take a look at the queries we're going to be running. First one is from my daughter. She wants to know how many red sweets are left, and she needs that answer straight away. She's just going to keep asking until she gets the answer. How many sweets are red, Dad? How many are red? How many are red? She's going to ask this many, many times throughout the day. So we need this query to be as absolutely fast as we can get it to be. However, my query to find the total weight of the red sweets, I'm only going to execute that a couple of times a day, and I can wait a couple of seconds for the answer. I'm a bit more patient. However, I'm not going to wait 5 minutes for the answer, so it still needs to be reasonably quick. So it may be we can get away with a smaller index, provided it enables me to find out how heavy the sweets are in a couple of seconds. If it doesn't, then we should go with the larger index. If it does, we've got a choice. Our overheads are low, so we could go with a larger one, but we don't need to, so we could stick with the smaller one. It's a toss-up. Let's look at a different scenario. What if instead we're the factory that's actually creating these candies? Now in this situation, we're creating candies thousands of times a minute, or maybe even per second. And we're shipping the candies off to customers at several times a day. So we're doing large batch deletes many times a day. This means we want as small and as few indexes as possible. Otherwise, we're potentially impacting factory operations and delivery to customers, which isn't good. Let's now take a look at the kind of queries that we might run in this situation. Well, for QA purposes, we still want to count how many candies are of a given color and find out their weights. However, this is something that is only done a couple of times a day. And the way the process works is we just start the QA process, and then the results are emailed out to the relevant people in the company. This means that no one's actually sat at a computer waiting for the answer. So if the query takes a few minutes to run, it doesn't matter. So in this situation, we should probably prefer the smaller index. And in fact, if we can get away with it, we want no indexes whatsoever, because the rate of change is so large. So how do you know where you sit between those two extremes? Low rate of change with high rate of querying versus high rate of change with low rate of querying? Well, this is something you need to do by looking at your existing systems and analysing its performance and usage, and also speaking with the people who actually use the system, your colleagues or customers who are running the queries, and find out what their tolerances are. How fast do they need things to get the results? How fast do they need their queries to be versus how much will it impact the situation if we slow down inserts and updates. Once you've got this information, you can then do some cost-benefit analysis and figure out which is the appropriate index for you to go for. I'm Chris Saxon. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.